my channel BK Tech. Today we are going to study about depth first search algorithm. So it is an algorithm for traversing or searching tree or graph in data structure. It starts at root and explore as far as possible along each branch before backtracking. So coming to the how the depth first search algorithm works. So in this we will start at a source node. So for let's say our source node is a 0. So we will then explore as far as possible along each branch. Then we will backtrack whenever it is necessary and repeat all these three steps until all the nodes are visited. So let's say our starting node was 0. So we will visit this 0 first, when then we will check that who are the branches of 0. So we can see that 1 and 4 are the branches of 0. So you can visit any of them, but let's say I'm visiting 1 first. So when I will visit 1, so I will check again its branches. So I can see that 2 and 3 are the branches of 1. So I can visit any of them, but I'm thinking to visit the 2 first. So then I'm coming back to 2. So if I'm when I visit 2, so I will mark it as visited, and then we'll check that who are the branches of 2. So I can see there are no branches of 2. So then I will backtrack to 1 and check who are other branches of 1 who are not visited. So I can see that the 3 is the branch of 1, but it is not visited. So I will go to 3 and mark it as visited, and the same way what we did with 2, we will check the branch of the 3. So if there are no branches, I will backtrack to 1, and then I will check with the 1 that who are the unvisited. So there are no unvisited node for 1 right now. So I will again backtrack to 0, and in the same way we will visit the right part of this graph, or we can say as a tree. So same way the 4 will be uh, visited and checked its branches. So 5 will be checked that it has no branch, then again we will backtrack to 4, and we will check with the 6, 7, and we'll again come back to 0. So let's say now we want to change the starting node. So let's say I kept the starting node for 4. So I can see now 4 has 3 branches. So one is the 5, another is 6, and another is 0. So let's say we can visit any of them, but I'm visiting 5 first. Then I am visiting once I completed the 5 node, as I have checked it's visited, and then I have checked it as that it doesn't have any branch. So I will again backtrack to 4. In the same way I will visit 6, and I will check its branches. So I can see it has one branch, 7, and I will visit 7 and mark it as visited, and check the 7 that it has more branch or not. So it doesn't have more branch, then I will again backtrack to 6, and then in the same way I will backtrack to 4. So I can see that it do have one more branch. So 0 is one more branch. So I will go now to 0. So I will go now to the 0, and then we'll check that which are the branches of 0. So now the 4 was the starting node, so it already visited, and 1 is the branch of 0 which is not visited. Then we'll come back to 0 1, and in the same way we will complete the this graph also, or we can see complete this tree, uh, the depth for search for this graph. Now let's come to the implementation part of the DFS algorithm. So we are given with the graph in the form of the adjacent list. So you can see that 1 is given, and 1 has a 2 adjacent, 2 and 5. In the same way 2 is given, which is having a 3 adjacent, 3, 4 and 1. And in the same way 3 is having a adjacent 2, and 4 is having a adjacent 2. So if we perform the DFS algorithm on this graph, so what will happen is that we are given with a visited array which is having a uh, which can be of type boolean, or boolean, and DFS answer array, where we store the answer of the this DFS graph. So we are given with the starting node which is 1. uh, so what we are going to do is that first we are going to put this 1 into the our answer array as well, and we are going to mark it as a visited also. So we have marked this as a visited and put it into the answer array. Then we will check who are the adjacent of 1. So you can see that 2 and 5 are adjacent in our adjacent list. So we are going to check that 2 is visited or not. So I can see that 2 is not visited. So I will mark it as a visited and put it into the answer key. Once this is done, I will check the who are the adjacent of 2, because in depth first traversal we go by depth. So I will check the depth of the 2. So I can see that the 2 is having adjacent of 3. So I will mark it as a visited and put it into the answer key. Now I will check with the 3, that who are the adjacent of the 3. So I can see that 2 is adjacent, but the thing is ki it is visited. So I will just backtrack it, come back to 2, like we do into the recursion, and I will what I am going to do is that check with the 2 that who are left unvisited and are the adjacent of 2. So I can see 4 is unvisited and is also uh, at a depth of 2. So I will come to the 4 and mark it as a visited and put it into the answer key. Now again I will check who are the adjacent of 4. So I can see only 2, but it is visited already. So I will backtrack again to the 2, only backtrack it. Then I will check that who are left which are adjacent of 2 and not visited. I can see 1 is given here, but the thing is ki it is already visited, and so I only will backtrack it and see who are left with the unvisited with the 1. So I can see that the 5 is the branch of 1 and it is still unvisited. So I will come down to the 5 and I will put it into the answer key as well. So mark it as a visited and put it in the answer key as well. Then in the same way we will traverse this. We will go to the 6, mark it as a visited, and then we'll backtrack to 5, and then we will check who are the unvisited branches of the 5. So I can see 7 is unvisited, and then we'll mark it visited and put it into the answer key. In the same way, I will put the 8 into the answer key and mark it as a visited. So once the all node are visited, I will again come back to the uh, backtrack to the 1 and see if any nodes are left which are unvisited. So I can see that no nodes are unvisited. So now our DFS traversal is completed. Okay, now let's come to the coding part of the DFS algorithm. So here is a GFG problem, or DFS of graph, which is having a zeroth vertex as starting node, and it's a left to right graph. So now we are going to first declare a one Boolean array, which will be of size number of node plus 1. Now we are going to declare one array list, which will store our answers, and it will be of integer type. Now we are going to make one more function in this, which will be our recursive function for this. So we are going to declare one static function. So static function do have a property of calling only uh, static methods, and it can use the only static variables. So it is a good for us. So we are going to make one DFS function which is of return type of void, because we don't need any return in this function. Need to return anything. We just need to run the uh, operations. We can take this adjacent list as it is also. And one more thing we need to add in function is our Boolean array. Now we are going to mark the node which are visited, which have been called in this function. So we are going to mark it this node as visited. Then we are going to add this node in our answer also. So then we are going to apply one for each loop on adjacent array. And in this we are going to check if that node which we are extracting from the adjacent array of that index is visited or not. If it is not visited, then only we are going to proceed into that. So we are going to again call this function with the node which we are extracting in this for each loop. So then we are going to call this DFS function again and again until all the nodes are visited. And from here this DFS function will be first called. So 0 is always the starting node. We can keep it here. Then our DFS answer array, then our adjacent list, then our visited array, and then we can return this DFS answer. Now you can compile and run. So you can see that our output is matches with the expected output. Now you can submit this. So this is submitted. All test cases are passed. Thank you.